You're listening to China Manufacturing Decoded from the Sofeast Group. Hello, welcome back to the podcast. Adrian hosting again, and Paul Adams, who's our head of new product development, joins me. It's somewhat of a British takeover again, guys, and it's episode 237 of the podcast. Welcome back, Paul.
Well, Adrian, it's good to be back, and a familiar tone in your voice. Let's see. Yeah, I recognise the accent.
Yeah, that's it. That's it. Although not from exactly the same part of the UK. Actually, you're from down south, as we would call it, and I'm from the Midlands, which of course is the best part.
Yes, one could say that.
But yes,
Anyway.
yeah, we'll try not to be too local for our international listeners. So, Paul, you're based generally in Agillion, which is our contract manufacturing subsidiary. Although we do so much stuff at Agillion in South China that it's almost just saying it's a contract manufacturer it's not enough. So we're going to kick off by talking about the different types of manufacturing that you're likely to encounter when you are outsourcing manufacturing to a supplier in Asia, could be China, could be wherever, because manufacturing, it's not one thing. There's actually many, many different things. So in your experience, you're going to be able to shed a lot of light on the different types of manufacturing. So as anyone listening who's sourcing, this is going to be helpful information, and that's going to be mechanical and electronic.
Yeah, pretty much so. And basically what I want to do is keep this fairly high level and keep a holistic view of where we're going here. Otherwise, it's going to be a whole podcast on one title, let's say. So, it's if you want to know any more information about anything specific that we're talking about, drop us a line, leave a note, and we're sure to be covered up for you. But as it is, what I would like to do, Adrian, as you said, is cover the different types of mechanical manufacturing processes without going into too much detail. Just talk about the actual machines or the processes themselves that are available to us as engineers for manufacturing components. I'll then switch over to more the electronics and PCB side of things. Okay, so let's start with the mechanical engineering side of the manufacturing facet to start with.
Great.
That's all right. Okay. So let's start with machining. So when you talk about manufacturing, in my mind, certainly the first thing that comes into my mind is you're going to be walking into a machine shop. Okay, so you in the machine shop, you're going to see a number of different machines, well, obviously. So and that could range from your standard 2-axis / 3-axis mills, a simple lathe, drilling machines. This is your basic workshop setup with these basic machines. But you can then expand up on that and the more technical products that require tight tolerances and different shapes and more complex geometries to be machined, you do need additional pieces of equipment past those basic machines to start with. And then we're talking about machining centers or CNC lathes and mills to start with. And these days, some of the machines are, let's say, huge. I've witnessed, just over the past few weeks, walking around our plant as well as subcontractors that we're using and some of our close partners that we've got. They've got massive machines. They've got 5-axis machines, 6-axis machines that are not only a mill, but a lathe at the same time, and they can do anything. It's absolutely incredible. So to see some of these machining centers, don't worry about what your product shape is, because these guys will be able to knock it out in precision format, so which is great. Another one that struck me as like, oh, I remember this in my previous careers, let's say when I was doing some gears or something like this, is broaching. Now, not everybody's come across the term broaching or know what broaching is, but it's basically you've got an internal bore and you need to put a keyway in that bore. You need to machine that out. And the way to do that is a broach. And basically it's a long sort of 12-inch up to a meter, 12-inch, I'm mixing dimensions here, up to a meter long tool that gets pulled through the bore in a precision that it cuts the square notch that you put your keyway in. This is broaching. Okay, so as a quick explanation what broaching is. I don't see many of those around, only if you are in gear manufacturing or if you need something that's splined, in other words, a positive drive from a shaft through to a cog or another cylindrical part that goes onto it, matching. So broaching is another thing that you should be looking out for. Now, when we're talking about machining, we're talking about material loss, which is like you've got a material, you're taking material off of the main block of material to produce your final product. Okay, so we're removing material. Another way to do that is via abrasion machining. Okay, so your typical ones here are grinding. Everybody has seen a grinding machine where you got the sparks coming off the ends, which is all good. Getting back to my gear hobbing days and gear manufacturing days, we've got a honing. Now, a honing machine is a finishing machine which has very fine stones that are rotating as well as moving up and down, reciprocating, and it gives you a very fine, high tolerance bore. Okay, so that's honing. You got lapping, very, very similar process, but more of a horizontal plane with the lapping wheel rotating in a cylindrical fashion, going round and round runs. And that also goes with polishing. All of these are machining aspects from a mechanical point of view. Now, lapping, honing, polishing, and grinding tend to be more of a finishing process that gives you the final dimension accuracy or the final surface finish requirement. Okay, so that's an important differentiation between the machining centers that we were talking about earlier. So your machining centers are one thing that can hold a certain tolerance, but if you need something as a higher tolerance or a more accurate tolerance, tighter tolerance, then you would have to go to one of these abrasion machining processes. Okay, so that's the differentiation there. Go together, work together, I always have done. Another thing we're talking about is forming. Now, forming, in my mind, that means sheet metal work. No, yep, it does. So for sheet metal work, we've got stamping, we've got bending, we've got drawing, we've got forming. Okay, all of those are to do with sheet metal and the way that the sheet metal is processed. Okay, stamping stamps out the shape. And then from there, you can either bend it or form it or draw it. And so all of these processes give you a semi-finished or a finished sheet metal product. Okay. But we're also talking about injection molding and die casting. That comes under forming. So if you've got an injection mold tool or die cast tool that has a cavity of the final product shape, molten material, whether that be a polymer or a metal format, is injected or forced into the tool, filling in the cavity, creating the cavity form. So we're forming the material through this process. Okay, so there's another forming aspect when it comes to mechanical engineering. Other ones that are using this forming process is blowing. Now, yeah, you're talking about blow molding, but you're also talking about some glassware that can be blown as well. We've got a number of different projects that we've seen come through the process that have required some sort of glassware. And they're all blown. Most of those are blown, as well as some of the plastic, let's say, bottle-shaped products. They're blow molded. Okay. So again, you've got to look at the process versus the requirement or the design of the product, and then try and match those two up from what is best suited. Another simple forming one, this is more of a heavy industrial process, which is forging or drop forging. You put a slug of metal between two very heavy dies. It comes down under force, and that's, again, forms the final shape of the core and cavity within the dies, and you've got your final product. You might need to trim the edges where you got the access flash and stuff like this. But basically, forging is a very good process when it comes to forming your final product. And another one is that I've worked with a lot in the past as an extrusion. So very, very simple explanation, if you're not familiar with extrusion, is the toothpaste tube. Okay, so your toothpaste is full of toothpaste, let's say, and you've got a small aperture at the front. When you squeeze, the toothpaste comes out in the form of that hole that you're squeezing out of. Now, extrusion is exactly the same. This can be extrusion of plastic or, in a lot of the cases that I've worked with in the past, aluminum or aluminium, where we come from, Adrian. So, you've got your bar stock being forced through a set of dies, where your final die is your final shape of the extrusion you want. Now, curtain rails. If you look around in the office, you've got all of the tracks that sort of things run around on, where you draw the curtains between the beds in the hospital. All of that is hung on extruded aluminum sections. Window frames, also all extruded. It's so much out there as an extruded aluminum. It's a very, very useful and popular process to manufacture materials, in particular aluminum. So that's forming covered quickly. And then, assuming that we want to start putting some of this together, we've got a joining process. Okay, now the obvious one again comes to mind is welding. Well, yeah, of course, Paul, we're going to weld our steel together. Yeah, fine. Oh, what about the copper pipes that we're using in one of our products to, from the compressor to another section within the assembly? Well, we can use brazing. And this is something that we've looked at just recently with one of our customers, Adrian, to be fair. They needed some brazing, and they'd done induction brazing instead of the traditional heating, where it's a similar process to welding, I guess, where you heat up the pipes and you're adding your solder rod, your brazing rod. But this time everything was pre-set, and the induction head goes around the joint, heats everything up, cools everything, and the whole process is done within seconds. It's really cool. Really cool. So very quick, very effective. And they say that depending on the equipment that we were using, they said 100% guaranteed every time. So, which is good. And the speed of this was very, very good. Other sort of joining processes, and this is really, I guess, where it comes over to electronics more, is soldering. When you're talking about wires and cables and components for electronics, this is your typical soldering methodology that you would use, as it were. But let's go back to non-electronics. Another one would be a very, very simple one: adhesive or glues, cyanacrylates, and AB formulas. Very, very complex adhesives on the market these days for very, very specific applications. And again, a glue is not just a glue. This is very much a science when it comes to identifying which glue is best for which application, which is really, really important to understand. So adhesives, very important thing to look at is the strength, curing time, and the heat resistance. All of these affect the selection of your adhesive. Now, adhesives, they are used in airplane wings, for example. So, when people say, you're going to glue this thing together? Are you sure? Well, yeah, we are sure. Because as long as you do your background, as long as you do your, you got to do your knowledge check. You got to make sure you understand what adhesive you're using and what application that is going into, and do your tests, then everything should be okay. Again, remind me to talk about the glue machine later, Adrian, that we've got. Now, two other things I want to talk about when we're talking about joining two parts of a product together, or two similar products. And this could be a plastic, or it could be a metal, a steel, something like that, is friction welding. So this is a very common application for construction work, for example, where two parts are put together and a longer rod is created by friction welding as a very solid joint and not to be sort of messed with. So don't see that very often these days where, in my experience, let's say, I don't come across that very often these days, but certainly out there and is used. And it's one of those things that should be looked at if the situation occurs. Last one I want to talk about, which is a little bit like, really? Yeah, is sewing. Okay. Yes, sewing in manufacturing is a big thing, believe it or not. So if you look around in your office or wherever you are at the moment, and not everything is hard plastic. Okay. I've got a couple of things that I'm looking around now that, guess what? They've got some fabric involved in the assembly itself. And that fabric needs to be cut, it needs to be assembled, that needs to be sewn together, okay, in a set shape in order to be assembled onto a product, or actually is the product and parts are put into it, for example. So, sewing is one of those applications that often gets overlooked from a manufacturing point of view, from a product design and assembly point of view. So, like I said, I'm going to rattle through these really, really quickly. So that's where I am from a manufacturing point of view. Like I said, if anybody out there wants any more information on any of these specific topics or notes, let us know, and then we can dig into that a little bit deeper. Now, before I move on, I'm just going to sip of water, Adrian, before we go on to electronics. That was your cue to do something.
Oh, okay, right. I was just going to pause while you sip, and then and then we can move on. That's fine. All of this is going to get cut out anyway. Okay.
Yeah.
That's fine.
Sure. That's why I left the big.
That's fine. That's fine. 3, 2, 1. Well, I think the processes that you've spoken about so far, for all the folks listening along, I mean, think about how are these going to affect the product that you're making, which ones seem appropriate for you. And I think it's good to touch on them, because if you are encountering these and somebody mentions it, like a supplier mentions it, and you've not heard of that before, well, now you have.
Well, exactly. Some of those, not very, you don't come across them very often. Is if you don't know, you don't know. That's the thing. And I'm not saying I know everything, but these are just, some of the things that I recall, in my past that I have seen. So, sharing the knowledge.
Perish the thought, Paul. Of course you do.
Yeah, I've been around the block a few times, as they say. So, okay, that said, let's move on to electronics and what we're talking about, electronics and various different things with manufacturing. And it all starts with a PCB. And I suppose it all ends with a PCB, really. But, a PCB doesn't just like create itself. There's quite a bit of work that goes into that. And I had I want to say rare pleasure, but it was, it's only the second time that I've actually been around a PCB fabrication plant in the whole of my career. Just recently, and that was last week, and that was very special actually. And I shall talk about some of the steps that go into PCB manufacturing, but it doesn't start there. It all starts back at the design desk in front of the computer where we've got the schematic. Now, the schematic is where you look at the different components, you look at the IC, you're looking at the sort of the communication devices that you require within the design. Maybe you've got a Bluetooth chip requiring some connectivity. So it all starts with a schematic where the design is put together from let's say, a sub-assembly point of view from the electronics aspect. Okay. So all of your power stuff is one area, while all of your communication stuff is the other area. And everything, there's rules and regulations, which I think we may have touched on before, Adrian. If not, we can certainly do that again with respect to best practices for laying out a PCB. And these should be followed. I'm not going to go through them now, but there's certainly best practices when it comes to designing a PCB and your schematic and certainly your layout. Now, the layout is the next step. Okay. So we need to design what the physical board is going to look like, what your tracks are going to be, taking around, where your IC is positioned, where your Bluetooth chip is positioned, where your USB connector is going to be positioned, and all of the tracks connecting all of the different elements within the board itself. that is your PCB layout. Okay, and some of the PCB layouts could be very complex. It's not just like a single layer. Some of these PCBs these days could be multiple layers of very intricate sort of design and layout work. Sort of very, very complex, some of these sort of PCBs. So this requires a lot of skill from the engineer doing the schematic and particularly the layout. Okay, so this is really, really important. The result of all of this is what they call a set of Gerber files. Now, the Gerber files has a number of different files within that folder itself, and this is one of the things that the PCB fabrication manufacturer requires in order to produce the PCB. Okay, and that will include your drill patterns. That will include your placements, your vias. Your vias just means going from one layer top to the bottom with a connectivity through the board itself. So once you've got your schematic done, you've got your layout, you've generated your Gerber files, then you start to look at your PCB fabrication and working with your supplier there. Now, very few people have this vertically integrated into their factory simply because of the rules and regulations on the chemicals that are used in order to produce these parts. And this is why you would see just a PCB manufacturer, and that's all they do, nothing else, nothing more. And everybody goes to them because nobody wants to get involved with all of the chemicals that are used and all of the licensing required in order to manage all of the waste chemicals, etc. So this is why I was quite lucky and privileged to actually go around this very, very large PCB manufacturing factory last week. Very impressive. Anyway, let's go through the steps, the standard steps that go into making or fabricating just your bare PCB. No components on it, just your PCB. So to start with, we've got the substrate. Now, the substrate these days is generally FR4, which is a fiberglass epoxy laminated sort of product. And this is generally comes in a green color. It can come in a red color or brownish color. And it's stiff. It's fiberglass. It's a solid one. But you also have flexible PCBs. I'm not going to go into that now. I'm going to stick with your standard FR4, what we call the FR4 solid PCB. So that's basically where we start with the substrate. You then put a copper cladding on top of that. Okay, when this is a thin layer of copper and it's bonded on both sides, so top and bottom. Okay, or top and switch it over. So it's two-sided copper covered fiberglass epoxy laminate. So that's where we are on the second step. The next step is photolithography, which is a light-sensitive application where they put on the tracks. Basically, it's the masking of the areas that you don't want showing, or you need the tracks. Everything else gets washed away or etched away, which is the next step. So it's basically a masking aspect, but it's a light masking aspect. Okay, because the next step is the etching. So anything that is exposed to the chemical, this is where the chemicals start to come into play. And these things run through. The one I saw last week, the chemical bath must have been about 50 meters long. It was incredible. Wow. And there's so many PCBs going through there. And they're not small PCBs. We're talking about the big format, 400 or 500 millimeter panels going through there, just continuously going through there. They go in, if you look at it, if you go in as a solid copper plate, and it will come out the other end with etched PCB. It looks like your PCB. Okay, this is where your previous step, step applies that masking, which you're masking off what you don't want etched off. Okay, so the etching removes and leaves the desired copper traces that are your PCB starting point. Okay, now then you got your drilling. Now each of these components, or each component, more often than not, has a hole or a small hole on the PCB. A set of holes there needs to be drilled. Now again, the plant I visited last week had a very good setup with CNC precision drilling machines. They had about 10, maybe 12 of these machines. Each machine had 4 stations. These guys were pumping out millions of PCBs, Very good. So the next thing after, once you drilled all the holes in the relevant places and the vias, which we talked about earlier, which is going from one layer to the next, we got the plating. Now, a thicker layer of copper is then plated onto the traces and the holes. Okay, so that's basically where we're going there. And then we got the solder mask. So the solder mask is a protective layer which is applied to prevent the solder from bridging between the traces. Now, this is super important when we're coming to the smaller PCBs, the very fine tracks, or anything with an IC that's got a BGA, ball grid array connectivity under the IC. And basically, when it's soldered, you can't see whether that's connected correctly or not. The only way to detect any errors or bridging. Now, a bridge means that 2 points of soldered together forming a short circuit. Okay, so we can't afford to be having that in an area which is sensitive, i.e. like the underside of an IC, integrated circuit board, that is. Okay, so this is where we are. And then we've got the silk screening. Now, the silk screening just gives you identification throughout the sort of the PCB on component placement, what the components are, identification, your company logo, for example. And this is where your silk screening comes in. It's printed on and it's baked in the oven as a final step. So basically, this is the standard process. Sometimes the etching and everything like this, maybe the additional plating is not done or not required, but in essence, this is the step when it comes to the fiberglass or the FR4 standard boards that we generally use and see in most of our electronics in and around our lives.
So which is
good.
So if you're looking for a PCBA supplier, you want to go in and have a look. Are they following this particular process?
Well, the other thing that's really important here, which I haven't put in, is the amount of inspection required throughout the process. It's really important that your supplier should have, and this is not PCBA, which is the assembly part. This is just PCB fabrication. Okay, so just to double check that one. But the level of inspection that you should be looking for is that every single step of the process, before it moves on to the next step, there should be an inspection process. And some of these inspection processes, as they move forward, where we're looking at once the copper traces are in place, when it's still in panel format before it's broken out into the individual formats. Yes. Sorry, Adrian, it's a big thunderstorm, made me jump. So from an inspection point of view, what we really should be looking for is some very tight controls throughout the whole process. It's one of those things that I noticed last week in my visit to the supplier, where they had individuals checking the panel formats before they were broken out into individual PCBs, both sort of visually as well as an automated visual inspection. Okay, they had inspection everywhere, which is really, really good to see. The processes that a manufacturer should have in place, I was checking for, and this particular supplier had everything that I would look for and you should look for in a supplier for your PCBs. So which is great. Follow the process, make sure the inspection's in there, including final inspection before it gets shipped out to your supplier or yourself. So which is good. So that's basically your PCB. Once you've got your PCB, you need to start putting components on that. There's 2 ways to do that. There's what they call the old school, which is through hole technology. But these days, a lot of the components are surface mount technology, also known as SMT. Now, the way this is done is you've got you've got your board, you've got your PCB, right? You then need to put solder on that. So you'd run that through a solder paste station. From the solder paste station, if everything's automated, that would go into a pick and place machine, which is often the SMT, which is a surface mount technology machine. People call it that or shortcut that. So it goes into the pick and place machine, and this is a CNC, highly controlled, very high speed. It picks each individual component up. It knows exactly where on the PCB it should place it. It places it down onto the solder that is previously placed in the correct position on the board itself. And then once it's complete, everything has a computerized visual check before it moves out. Once it moves out of the SMT or the pick and place machine, and some of those have actually got the through-hole technology on them, some of the larger components particularly, it moves into the reflow soldering oven. Now, this is where everything settles down. The heat that is the elevated heat within the reflow soldering oven is not just, it goes in at like 200 degrees. This has a heat profile. So it starts off at a lower heat as it moves through the oven. Now, sometimes these ovens can be quite long. As it moves through, the heat increases to the point where the solder paste melts, and it does that fusing of the component and the PCB. So you got your solder tightly controlled from a melt point of view from the temperature. As that moves through the oven, the temperature then comes down. So you've got this very tight control of the heat profile as it moves through that reflow soldering oven. Okay. So at the other end, you've got your finished part. Another way to do it is wave soldering. So you got your reflow soldering, got your wave soldering. This is a very, very similar thing. It goes through the sort of the heating process in order to melt the solder to the point where it doesn't just flow everywhere, but it's very, very tightly controlled, and you get a solid, reliable solder joint on the component to the PCB itself. Okay, so you've got those two technologies that are often used. Generally, reflow soldering is for your SMT, and your wave soldering is more old school, I would say, for some of your simpler or very specialized components with through-hole technology. So that's basically, you've got your PCB at the end. Is that the end of the process? No, of course it's not. You need to go through the inspection and testing to verify that everything is okay. Now, previously, I talked about the difficulties of having BGA correct. BGA, let me remind you, is ball grid array. This is a tiny set of solder balls in rows and columns that solder the connections of your IC, integrated circuit, onto the PCB itself. And if they're wrong, it's the whole system won't work. Your PCB scrap. So you need a way of inspecting that, and generally that is done by X-ray. Okay, there's no other way to actually check whether the BGA has been soldered correctly, or if there's any bridging occurred or dry joints or anything like that. So X-ray, you have to have X-ray on any critical components where the solder joints, you can't see them. Everything else can go through electronic sort of visual inspection. Okay, so this is basically where we are there. You then, once you've confirmed everything looks okay from a visual aspect, you do a functional test. And this can be a simple jig where you've got your PCB and a jig, and you pull down the lever and it's got connecting pins on there, and it gives you a buzzer, a light, so the green light, red light, whatever the case may be, correct, wrong. So it's a simple test of saying, yeah, okay, we've powered this thing up and we've tested on certain points. A lot of the cases, Adrian, is where we've got the PCB, you'll have built-in test points where this is exactly what it's for, where the end of the line, they can, connect to a certain point and that will do something, turn something off, turn something on, connect to something. So these test points are what we're looking for in the functional test at the end of the line. Okay. So this is really important that these testing is completed before anything else. If everything passes through there, then we're all good when we've got a final product that we can actually ship out to the customer, and that's exactly what you should be looking for. And again, when you are looking for your PCB assembly supplier, make sure that they have all of the controls in place from a clean room aspect. So it should be a dust-free. You have to make sure that your PCB supplier is using anti-static material everywhere. Check the footwear, okay, of if you're going to go around, or if you look at the photographs of the supplier that they're supplying, look at their factory, check the footwear. Okay, it's a simple check, because everybody should be wearing blue slippers. Blue slippers is the anti-static ESD protection to stop the electrostatic sort of building up, discharging, and potentially destroying some of the components that they're putting onto a PCB. Simple check, but that's easily done. Anyway, I think I wrapped up and probably overspent my time on electronics.
No, I think it's important because, look, so many of the products that people are making are at least have an electronic component, right? So this is quite relevant. And you've spoken about the different types of mechanical manufacturing, so just bear those in mind when you're sourcing. And then you've kind of gone through the whole steps of electronic manufacturing, starting with the PCB and ending up with, checking that everything's functioning correctly. So that's more of an electronics focus, and I think really good to cover. So that's your lot for another week from the podcast. A useful look at the different types of manufacturing that you are likely to encounter when you're sourcing from Asia, and what they commonly do and what they're used for. So if they're ringing a bell and you're like, yes, actually, we do need this kind of manufacturing process when we are looking for our new supplier, now you have a better idea of what you're looking for and what's likely to be offered by them. So back again next week as normal. Don't forget to like and share the podcast. Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.